Hey AP Physics students, Jock here for an explanation of what the homework was. Look at number 1. In this situation we have at what position in the above circuit will the charge passing that position in 1 second be the largest? Now you know that charge in a certain amount of time is called current. So this question is really asking is which points have the most current? So as I kind of taught, I want you to take and draw the flow of current from one side of the battery to the other. So we start off with an arrow starting from the battery, going through the 50 and reaching this junction. We're going to call that IT or just I. At this point, it splits into 3 different paths. I1, I2, and I3. I1 goes through B, I2 goes through C, I3 goes to D. And it comes back, and this point right here, it reforms back into the original I. So in other words, we're trying to figure out which one of these points has the most flow. It's obviously A, because all the current of the circuit flows through it, whereas B, C, and D have only part of that current. Now if you had to rank them entirely in order, it would actually go A, B, C, D. Since this path has got the least resistance of the 3 parallel paths, it has the most flow. So that's not too bad. Let's go on to number 2 now, which is maybe kind of the toughest ones to understand. So looking at this problem, the question says, in the figure above, 3 resistors are connected to circuit the battery. Which of the following correctly ranks the energy dissipated or given off by the 3 resistors during that time period? So all the same time period. We know power is energy times time. So pretty much we're saying that what's the power of these 3? And we know that power is either I squared R or V times I from before the break. So we're going to make it a lot simpler. We're going to compare the volts and amps. So we first have to look at these and see which one of these has got the most amps. Well, the 100 and 300 are in series, so they have the same amount of amps. But together, their path is 400 ohms. The other path is 200 ohms. So more amps flow through the 200 than through the 100 and 300. So the 200's got the most amount of amps. Furthermore, the amps of the 100 and 300 are the same, but the voltage is split up between them. Now, combined, their voltage equals to 200, because in parallel, the voltages are the same. So the 200's got the most volts and the most amps. It has to have the most power. The 100 and 300 have the same amps, but they must have different amounts of volts. Here's how I want you to think about it. If they have the same flow, which one needs more push to make that flow happen? Obviously, the 300 has more resistance. And if you have your little paper from the first day back with the summary, you see that more resistance in a series is more voltage. So to summarize, the 300 has the same flow as the 100 because there's only one path in that branch. And the 300 has more voltage. Same current, more voltage. The 300's got more power and energy. That's why it's letter C, the 200, the 300, and the 100. Let's keep going. The 6 circuits below all have 1 battery and 3 resistors. All the batteries are identical, so they all have the same volts overall. All the wires are identical, equal length, negligible resistance, so we don't care about the wires. Rank these circuits from greatest to least on the basis of potential difference across the circuit resistor. Potential difference, you saw that in the past. Also in the most recent activity with computers, I actually crossed out every word of potential and wrote the word voltage in. So what's really asking is, rank the voltages of the circled ones based on what the circuit is. Now it's really easy to look at these and say, oh, the 20's got the least volts and the 60's got the most because more voltage happens when there's more resistance. But what we have to take into account is that they don't all have the same amount of overall resistance. In A, for example, 20, 40, 60, there is 120 ohms overall. But in E, 20, 20, 40 is only 80 ohms overall. Obviously, 20 ohms out of 120 is less of a share than 20 ohms out of 80. So what we're going to do is we're going to figure out the kind of percentage that each circle is of the total resistance. And so I found the total resistances from A, B, C, D, E. And since they're all in series, you just add them up. And then I found the fraction of what the circled is of the total. A is 1/6, B is 1/2, 1/3, 1/3, 1/4, 1/2. So obviously in A, if the circle one's got 1/6 of the resistance, it's got 1/6 of the volts. B has got 1/2 of the volts, and since they all have the same overall voltage, that means B is more volts than A, and I ranked them up that way. Now for number 4. Number 4 is determine the equivalent resistance between points A and B. To do this, we need to look at the overall paths. So following my little cursor here, the total current starts from A. At this point, there's a split, so there's a junction. Some of it goes down through the 3. The rest goes up through. At this point, it's another split. So it goes through 12 and 4, combines, goes through the 3, combines, and it's back. So the top path is in parallel with the bottom path. That does not mean that the 12 and 4 and the 3 are each individually parallel with this 3. It's like their entire combination's in parallel. So 12 and 4 are obviously parallel. They both have the same start and end junctions. If you do the mathematical equation, 1 over REQ equals 1 over R1 plus 1 over R2, you get 3 for this. I then redrew the picture with these two replaced by a 3, and I realized that the top path is now a 3 and 3 in series. That can combine to be 6. So now the top path is pretty much a 6 ohm. The bottom path is 3. These two paths are parallel. I used the same equation again, and I got 2 ohms for my total resistance, thus letter D. And then finally, number 5. Good summary statements here. When 2 or more resistors are in series, A, does the voltage of each one combine to equal the total? Well, yeah, we saw that. B, does the current have the same flow through each one? Yeah, there's only one path. No matter how big or how small the resistance, you have the same flow. And C, the equivalent resistance equal to all the other resistance added together. Absolutely right. Therefore, D is the correct statement. And for parallel, A, the voltages across each resistor is the same. Yes. If two things are in parallel, they must have the same voltage. B, the total current equals the sum. Yeah. The current going in equals the amount of current split up added together. C, the equivalent resistance of the combination is less than the resistance of one of the resistors. This is kind of tricky, but it's true. No matter what, if you have, like, for example, 2 2s in parallel, you get 1 for the overall. If you have like a 3 and 2, you get like 1 point something. No matter what, the overall in parallel is equal to the combination of the parts, and you always get less than each part. So that's why it must be D. Hopefully this kind of gave you a quick little review of some of the things I may have done. Look at the answer key as well as I saw it on here, and come to class with questions. Bye.